Hello everyone, I am Dr. Sirajul Haq Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about chemistry practical. So I will discuss about the basic knowledge for chemistry practical in this video. Mole concept, volumetric analysis, titration, physical chemistry like energy change, reaction rates and solubility. I will also discuss in this video about the qualitative and quantitative analysis in organic and organic. Now, you know the important skill required in chemistry practicals. You should know the manipulative skill, observation skill, reading skill, recording skill, computing skill and interpreting skills. You know the practical is meant to assist the learner to learn and develop the following skills. So I am going to repeat: manipulating, observation, reading, recording, computing and interpreting skills required for chemistry practical. Now, what is meaning of manipulating skills? It involves the correct and skillful handling of the apparatus by the experimenter. Observation skill means involve the use of sense, hearing, sight, touch and smell to detect changes and reaction. Reading skill means refer to the ability to comprehend written or printed informations. Recording skill means intel writing down for examples, measurement or statement of facts or other details for reference. Computing skills means involve the use and applications of mathematical knowledge in data collections. Interpreting skill means involve studying the data collected and drawing conclusion based on the established chemical principles. Now, area to consider when preparing for the chemistry. So, chemical symbols must be written correctly. That is, when the chemical symbol is just one letter, it must be in capital. If two letters are used, the first must be capital and second one be a small letter. They must be separate, not joined. The small letter must not be bigger than the capital one, so must not be shaded. Now, in the chemical formula, any letter that represents one atom of an element must be capital, sodium carbonate, and not sodium carbonate. Look at here how people writing in place of oxygen. You can see this. This is wrong. A chemical equation must contain correct symbols and formulae, balance and state symbol to show the state of matter of each of the substances involved. Now, writing observation must be based on the following. When there is a color change, both original and final color must be stated. Color and smell of gases should be stated. Color of precipitates should be stated. Color changes for both blue and red litmus paper must be stated when used. Color of solution must be stated. Now, a procedure must be correct to the letter. That is very important. Soluble salt must be prepared by adding excess metal to an acid, metal oxide to an acid or metal carbonate to an acid. In separating a soluble solid from an insoluble one, start by adding convenient solvent to the mixture. Do not say dissolve the mixture. Insoluble salt are prepared by precipitating, mixing two solutions. Indicate what happened at each steps. Now, when naming or identifying substance, do it as follows. When the questions leads identify, either the name or formula is allowed. But when the question lead name, when just give the exact name, the name of ions are not allowed, only correct formula are accepted. If you give both the name and formula, both must be correct. When plotting graphs, ensure they have the following: label, axis, appropriate scale, plotted point must be visible, all points in the table must be plotted correctly. A convenient scale must make the graph occupy at least 3 by 4 page. A straight line must be drawn with a ruler. Smooth curves must be drawn free hands. Now drawing diagram. What you need to do? Must be correctly drawn. Apparatus should be proportional. Labeling must be workable, no leakage of the gas. The condition under which the reaction were carried out must be stated like catalyst, a specific temperature or range of temperature, a specific pressure, a specific concentration. Notable point is here abbreviations are not accepted like PPT instead of precipitate. Filling the burettes. First, rinse with about 5 cubic centimeter of the solution with which it is to be filled. Discard the portion of solution used to rinse it. Fill the burette with the solution to the mark. The level of bottom of the meniscus is then adjusted to be at the same level with the 0 mark, and this is taken as the initial reading. Any convenient mark may be chosen as the initial reading for any other subsequent filling. So this is about the how you fill the burette. Now writing ions in words and wrong oxidation state is not acceptable. Ions should be written in their symbols and correct oxidation state like Zn2 plus, not Zn plus 2. Zn2 plus, that is important. When mixing two solution, it's wrong to write no reaction, no change, no chemical change, and clear solution formed like this. Correct observation should be a white precipitate formed, clear. A colored precipitate is formed, no white precipitate is formed. Now there is no white nor whitish solution. A solution is colorless if no color is seen in the solution. Do not addish to colors of precipitate of solution like copper solution is blue, not bluish. Simple blue, not bluish. Using volumetric flask when diluting solution. Measure the required volume of solution to be diluted and transfer it to the flask. Add more distilled water until the bottom of the meniscus is at the level of the mark on the neck. The preparing solution from solid substance like dissolve the solid in little water in a beaker, transfer the solutions into the volumetric flask, add more distilled water until the bottom of the meniscus is at the level of the mark on the neck of the volumetric flask. Now volumetric analysis, that is also important for you. This is especially in chemistry when deals with the measurement of volumes of solution of reactants, reacting them as you record the reacted volumes and using the information to carry out the calculation based on the data collected. So standard solution, analyte and equivalence volume. What is a standard solution? Is a solution of known concentration which is used in the titrimetry. Analyte, what is the analyte? Is the test solution whose concentration is to be determined. Equivalent volume are the volume of both the standard and analyte solution which react completely without any in excess. The end of the reaction is known as the end point of or equivalent point. Now commonly used end point indicators. For neutralization reaction, phenolphthalein and methyl orange are used. Redox titration do not require any indicator since they change color when reduced during the reactions. And KMNO4, here potassium magnate 7 changes color from purple to colorless. That is the wrong formula here. And K2Cr2O7, here is also potassium dichromate 6 changes color from orange to green. Now indicator coloring change. Methyl orange, acid red pink, base yellow, neutral orange. That is very important because if you don't have the memorizations of color, then you only observations, and during observation how you will compare. Screen methyl orange like purple, orange, orange. Phenolphthalein colorless in acid, pink in base and neutral colorless. Litmus solution acid red, base blue and neutral purple. Now the mole. The mole is the chemistry unit of measurements of the amount of substance. It is measuring unit, just like a dozen, a pair, or a gross. Example: a pair of shoes contains 2 shoes. A dozen shoes consist of 12 shoes. A mole of shoes consists of 6.023 into 10 to the power 23 shoes. So, in chemistry, mole of substance is the amount of that substance containing 6.023 into 10 to the power 23 particles. In this case, particle can be atom, ions, molecules, or electrons. The mole of substance may be represented by the chemical symbol or chemical formula of the substance referred to. For example, Cl represents the mole of chlorine atom, Cl2 a mole of chlorine molecules, O a moles of oxygen atom, O2 a mole of oxygen molecules, copper a mole of copper atom, copper 2 plus a moles of copper ions, and E a moles of electrons. Now, molar mass. This refers to the mass of 1 mole of substance, the unit of measurement for the mass in gram per mole.